fluency, it's the elephant in the room, but let's talk about it. Fluency has three different meanings: efficient, effective, and flexible. A fluent student is all three. So no matter which word we put in front of the word fluency, we're always going to talk about those three strands. Are they efficient at it? Are they effective at it? And are they flexible with it? So the first thing of fluency that we have here, of course, is fact fluency. Fact fluency is that basic fact mastery, kindergarten 0 to 5, first grade addition, subtraction within 10, second grade to 20, and grade 3 up to 12 by 12. Those are their fluency standards in which they can do them with ease. They are efficient, 3 to 5 seconds. They are effective, they get the right answer, and they are flexible. They have other ways to get that answer in terms of counting strategies, decomposing, composing, counting on, counting back, etc. Again, every strategy also has to be efficient and effective. So they might be flexible and know that they could do 7 ones plus 8 ones and then count all the ones, but that is not an efficient strategy, and that student would not be considered fluent. An efficient strategy would be 7 plus 8. I know 8 is 7 and 1. 7 and 7 is 14. Add one more, I get 15. So we want students to be fluent with their math facts. Now, are they going to work on other facts other than what's on my screen? Yes, they're going to work flexibly with those, continuing to build conceptual understanding and strategies. But what do they need to know by the time they exit this grade and be able to do with ease, efficiency, effectiveness, and flexibility? They need to have these. So a kindergartner should be able to say all the facts within 5. They should be able to say 4 is 2 and 2, 3 and 1, 0 and 4, 0 and 4. They should also be able to see it in print. 3 plus 1 equals 4. So they have a lot of fluency with those facts from 0 to 5, even though they also work on facts from 6 to 10 and their team numbers. After we get through fact fluency, which we're going to really build from conceptual understanding how to compose and decompose numbers and what those quantities actually mean, we use fact fluency to build computational fluency. So computational fluency is going to look a little bit different. Computational fluency says that I have something like 17 plus 44, and now I have strategies that I can use and different methods to solve 17 plus 44. I'm not going to just know that one in my head. I'm not automatic in it. However, I might use fact fluency to get there quicker. So I know that 7 plus 4 is 11 because I have fact fluency. But really, I know that 7 plus 4 is 11, which means I made a new group of 10 and I have one additional one. That is a part of computational fluency. I can apply computational methods to this multi-digit number. I'm using fact fluency to arrive at those computational fluency standards. So the principles and standards for School of Mathematics states computational fluency refers to having efficient and accurate methods for computing. They demonstrate this flexibility in the computation methods. They know that I could also go 1 10 plus 4 10s equals 5 10s. So they have multiple ways they can attack this particular problem. They understand and can explain those methods, and then they can produce accurate answers. So if I'm in second grade, I understand the regrouping and the ungrouping. I might understand partial products relating to the area model in fourth grade. I have computational fluency. I have multiple strategies I can use. I can explain them, I can defend them, and I can represent them. When I'm then working on something like, oh, let's actually use another one. If it's something like 70 is my total, and I'm trying to say 59, 70 minus 59. Okay, let's do that problem. If I know it's 70 minus 59, a computational fluent student might be able to say, well, 70 minus 59, and they think, oh, I might be able to put it on a number line. Maybe someone ungroups that group of 10 and they make it a 60. Okay, so I could do those methods. I could also say, well, 59 plus one more is 60, and then 60 to 70 is another 10. That's just going to be 11. Those are students who are computationally fluent. They know what to do with the numbers, and they have multiple strategies. Once we get from computational fluency, which is going to use fact fluency, we move into procedural fluency. And procedural fluency and computational fluency are often looped in the same span or same definition because they're very, very similar. In fact, we could probably say they are the same, but there's some differences and nuances to those terms. Are they really important nuances? Not necessarily in my book. You're going to still just see in the standards a lot of fact fluency versus procedural fluency. But procedural fluency is basically carrying out the procedures with ease. So now I have chosen a method. So maybe I was choosing that partial products method or show all totals method from left to right, or another particular method, if you will. And now I can do it with ease. I know exactly what step to take, when to take the step, how to take the step. So I don't have to think about my next step in that long division process. I just know what it is. I am going to use computational fluency and fact fluency to build procedural fluency. So I still have to know some basic facts, and I have some computational fluency, meaning I can choose which method is the most efficient or effective for this particular scenario. And then whatever method I choose, I now have procedural fluency, and I can carry out that fluency standard with ease. Those are the three types of standards or three types of fluency and how they may impact you in your math classroom.